welcome to the second lecture of the fluid mechanics, where we are doing things especially from an exam oriented or uh, point of view where we can solve the majority of the numericals in any exam, any type of exam. Okay, so previously we had discussed about the Newton's law of viscosity, and we had solved some numericals as the common type of numericals which appears in exam. Now today we are going to deal in the surface tension. So first of all, before solving the numericals and giving the theory, we have to know what is surface tension, right? So you can, as I told you before starting the lecture, you can just take your copy, pen, and the calculator to begin with, and also give the video a like because it helps in the YouTube algorithm. Okay, so surface tension can be defined. It can be defined as the tensile force acting on the surface of a liquid with a gas or on the surface between two immiscible means where these liquids cannot be mixed, immiscible liquids such that the contact surface behaves like a membrane under tension. Okay, so surface tension, it is also denoted by sigma. On the numericals you will find it is denoted by sigma. What is surface tension? Whenever you keep a liquid, so the liquid is in touch with a gas, so the tensile force acting on the liquid surface, okay, is known as the surface tension. And also if you have two immiscible liquids or two liquids which do not mix together like oil and water, so then the layer will be formed between this oil and water, so the contact surface behaves like a membrane, and the tension acting on the this on any of the two liquids is also known as surface tension. Now surface tension is denoted by sigma, and sigma unit, as you know, in this fluid mechanics, you have numericals in your SI as well as an MKS unit. So sigma in your MKS units is kg into force, okay, kg force per meter, right? And in SI, obviously sigma in SI unit is your Newton per meter, right? Newton per meter. So it is kg force per meter and it is Newton per meter. So this is the difference in SI and all. We can easily convert it, kg into 9.81, it will be turned into Newton. So that's how we can convert it. So now surface tension, mainly three formulas we have to remember for surface tension. There are other things as well which we need to know, but primarily we have these three formulas which you need to remember. So surface tension in liquid droplet, okay. So liquid droplet, any liquid droplet surface tension, if the question comes in liquid droplet, which formula you need to apply? So you need to apply the formula, that is P equals to 4 sigma by D. So what is P and D here? P is the pressure intensity inside the droplet. So you have to just do it. So it is the pressure inside intensity inside the droplet. So P is the pressure intensity inside the droplet and D is the dia of droplet. So any liquid droplet, the relation between the pressure intensity and the diameter is P equals to 4 sigma by D. Sigma is the surface tension, 4 into sigma by D. D is the dia of the droplet and P is the pressure intensity inside the droplet. So question comes, you ask may come for find out the surface tension, or question may come to find out the pressure intensity as well. Now this is a droplet, and if this droplet is a hollow bubble, so what is the surface tension we'll know here. So next topic is next formula is surface tension on a hollow bubble, right? Just to write it down, surface tension of a hollow bubble. So the formula is P is equals to 8 sigma by D. P is equals to 8 sigma by D. So this is the formula for the surface tension of a hollow bubble. Same, only in a liquid droplet is 4 sigma by D, and in a hollow bubble it is 8 sigma by D. The next which you need to remember is your this also question comes of this type, surface tension on a liquid jet. Okay, so liquid jet surface tension we need to know. So P is equals to 2 sigma by D here. So P is equal to 2 sigma by D. So these are the three formulas, and using these three formulas we can solve some of the numericals. So I'll give you one numerical from this, how to apply these three formulas, and after that I will also study a bit about the capillary tube. So once we study a bit about the capillary tube, then we'll do mainly two more numericals of the capillary tube part as well. Okay, so we'll solve the first numerical. Let's start. So write it down along with me. The surface tension of water in contact with air at 20 degrees Celsius is 0.0725 Newton per meter. The pressure inside a droplet of water is to be 0.02 Newton per centimeter square, greater than the outside pressure. Okay, so this is greater than the outside pressure. Now the next part is calculate the dia of the droplet of water, right? Calculate the dia of the droplet of water. So this is it. The surface tension of water in contact with air at 20 degrees Celsius is 0.0725 Newton per meter. The pressure inside of a water droplet is 0.02 Newton per centimeter square, greater than the outside pressure. Calculate the diameter of the droplet of water. Okay, so first of all we need to know what are the things which are given in this question here. So surface tension is given. So surface tension is sigma is equals to 0.0725 Newton per meter. The surface tension, just write down the surface tension at 20 degrees Celsius is a normal temperature, nothing to do here, and the pressure inside the droplet is to be found out to 0.02 Newton per centimeter square. So pressure is given, so you need to convert it into SI unit, 0.02 Newton per centimeter square. So Newton per centimeter square, centimeter to meter is 10 to the power 2 into 10 to the power minus 2. So 10 to the power minus 4 in the bottom, in the top it will be 10 to the power 4. So it will be 0.02 into 10 to the power 4 Newton per meter square, right? So you can also just write it for convenience, 2 into 10 to the power 2 Newton per meter square, right? Like this also you can write. So now what type of this is surface tension of with air, the pressure inside a droplet of water. So it is a droplet of water. So droplet of water formula is P is equals to 4 sigma by D, and if it be hollow bubble, then it would be P equal to 8 sigma by D, and if it be liquid jet, then 2 sigma by D. So 4, 8 and 2. So this is the thing of a liquid, hollow and the jet. So here we will use the formula P is equals to 4 sigma by D. So implies that D is equals to 4 sigma by your P. so is equals to 4 into, so what is sigma? 0.0725 Newton per meter, 0.0725 Newton per meter. And what is P? 2 into 10 to the power 2 Newton per meter square. So this D will be in meter here. So if you I'll just calculate it in the calculator. 0.725, 4 into 0.725 divided by 2 into 10 to the power 2. So it comes as your 1.45 into 10 to the power minus 3 meter. And if you want in mm, then obviously it will multiply 10 to the power 3, so it will be 1.45 mm. So D is 1.45 mm, or in meter also you can see it. Okay, so let's solve another numerical to just boost our confidence on these two formulas, right? These three formulas actually for the surface tension. So the next question, let us write along with me. Okay, so the pressure outside the droplet of water of dia is equals to 0.04 mm is 10.32 Newton per centimeter square. Now this is also the atmospheric pressure, okay, which is given. So this is the atmospheric pressure. So dia is given at the atmospheric pressure. So now calculate the pressure inside the droplet if the surface tension equals to 0.0725 Newton per meter of water. So here we have this water droplet, and the outside pressure and dia is given. So let's first just do the given data. Dia of the water droplet is given, which is 0.04. This is 0.04 mm, so 0.04 into 10 to the power minus 3 meter, right? Directly we write this, and then the then we have this this sigma. So and calculate this is 10.32. So for the outside, just to write outside, right? Outside droplet. So for the outside droplet, D will be the same. So outside droplet sigma is equals to 0.0725 Newton per meter, which is given in the question, and D we know, and P is the question mark. So normal formula for the droplet, P is equals to 4 sigma. Again revising, P is equals to 4 sigma by D for normal droplet, 8 sigma by D for the hollow bubble, and 2 sigma by D for the jet, right? So 4 sigma by D implies P equals to 4 into sigma, that is 0.0725, right, Newton per meter by your by D. But this will not be the case here, okay? This will, okay, so let's just solve this. So by D, so D will be here 0.04 into 10 to the power minus 3 meter. So just do the calculation here. I'll do it with the help of calculator. 0.0725 divided by 0.04 into 10 to the power minus 3. The answer will be 7250. So P is equals to 7250 Newton per meter square. So this is the answer of the P, which is found out. So now this is the pressure which we have found out, And again, as you can see, atmospheric pressure is given here in Newton per centimeter square. So better convert it to Newton per centimeter square for now. So Newton per centimeter square implies P is equals to, and meter square mean, if meter square to centimeter square, if you want to convert meter to centimeter, is 10 to the power 2, 10 to the power 4. If you multiply at the bottom, means at the top we will apply 10 to the power minus 4. So if you 7250 into 10 to the power minus 4 Newton per centimeter square, so which means 0.725 Newton per centimeter square. So total pressure inside the droplet, so what will be, it is equals to, this will be 0.725 Newton per centimeter square plus the atmospheric pressure which is given. Atmospheric pressure is given 10.32 Newton per centimeter square. So if you add it, it will be 11.045 Newton per centimeter square. So this will be the answer. So in this, only the difference is in this formula, after finding out, we add the atmospheric pressure. So if anywhere the question atmospheric pressure is given, the total pressure will be this plus the atmospheric pressure. So this is the these are the two numericals which we have solved for your water droplets using the three formulas which we have seen. Okay, remaining also will be the same for water jet also. The method used will be the same. Now we need to have some formulae for our capillary tube. Okay, so now is the time for doing some questions on the capillary tube. So let's slide here. Capillary tube, very common numerical in any competitive exam. Okay, so now first let's define capillarity, right? What is capillarity, right? So this will be single P, obviously. So capillarity is defined as a phenomena of rise or fall of a liquid surface in a small tube relative to the adjacent general level of a liquid Capillarity defined as a phenomenon of rise and fall of a liquid surface in a small tube relative to the adjacent general level of a liquid when the tube is held vertically in the liquid. So let's understand it. What is this capillarity with the help of a diagram? So suppose we have a liquid here, right? Liquid here, and we insert a tube. So this is the capillary tube which we insert, and the liquid will come up. So it will be in the shape of this like this, except mercury and some other liquids. So this will be the shape here, and surface tension sigma, it can be called this surface tension, and this height is denoted by h, and this is the obviously the liquid, any liquid which you find here, and this angle is also called your theta between the water and the glass tube, or the liquid and the glass angle. So this is called your theta, right? So whenever you insert a tube, some water comes up. So this is defined as capillarity. So capillarity is defined as the phenomenon of rise or fall. It can rise or fall of a liquid in a small tube relative to the adjacent general liquid of a liquid when the tube is held vertically in the liquid. So the smaller the generally the smaller the dia, then the height is more. So the relation between this is given by a formula, and this formula is your H equals to 4 sigma. Sigma, as we know, surface tension, into rho, as you know, density of the liquid. G is the your specific, your G is the this 9.81, which you take as g acceleration, and this is d. So now those, then another element is there, cos theta, right? So theta, first let's write liquid and glass tube or capillary tube angle, right? So d is the dia of the capillary tube. Dia of tube means here capillary tube here. So when I will say q, rho is the density of water. So g is simply the 9.81, right? Sigma is the, surface tension. Already know that sigma is the surface tension, right? So now for rise, theta is equals to 0 for most liquids except the mercury. So then h cos 0 equals to 1, so then h becomes 4 sigma by rho g d, right? This is the formula, cos theta equals to 0, when big then it becomes this. Now we have to understand the capillary fall. So for liquids like mercury, the capillary fall occurs instead of the rise. Okay, so mercury is very special liquid, and the capillary fall occurs in the mercury, right? So the shape is actually like this, kind of like this, and you can see there pressure being applied here is like this. Theta obviously will be like this, theta will not be 0 here, and this in the along this segment sigma or the surface tension will act, right? And this is the mercury, you have to write mercury. So this is the fall example, fall. So now in this case h will be depression in the tube, right? H is the depression in the tube. So this is the h, depression in the tube. So depression in tube, right? It will better be height of depression in tube, height of depression in tube. So h equals to, what was the earlier formula, 4 sigma cos theta by rho gd, right? So it is also the same, 4 sigma cos theta by rho gd, only in this case this will be negative and theta will have a value, right? And if anything is not given in the question, then theta for mercury and glass tube. So the tube is of glass and the liquid is mercury, the theta is 128 degree, or else whatever is given in the question you can take it. If it is not given in the question, and if you know that the liquid is mercury and this glass tube is the tube is of glass material, then it is 128 degree. So let us do precisely two numericals now, just to understand the formula better, right? So there is basically one formula only, 4 sigma, height equals to 4 sigma cos theta by rho gd. For rise, your theta will be cos theta will be 1, theta will be 0. For fall, in the case of mercury, theta will be 128 degree, otherwise given in the question. 4 sigma, sigma is the surface tension, rho is the density, and g is the 9.81, and d is the dia of the tube. Okay, so simply let's just write our question here. So calculate the capillary rise in a glass tube of 2.5 mm dia when immersed vertically in, now this question has two parts, vertically in A, water, B, mercury. So by this question you will just have an experience of both the methods. Okay, now water, for water, sigma or surface tension is equals to 0.0725 Newton per meter, and if you have your mercury, that is for the question B, sigma is equals to 0.052 Newton per meter. Okay, and the specific gravity of mercury is equals to 13.6, angle of contact which we know as theta they have given as 130 degree. So we know that mercury specific gravity is 13.6, means rho will be 13.6 into 1000. We know that from the previous session. I'll also tell you here how now. First of all, let's answer by A. So A is the material is your water, so theta is equals to 0. So the formula, write again and again formula so that you can remember. 4, okay, 4 is common, sigma cos theta will be here 0, so 1 cos theta by rho GD, right? This is the formula. So and also remember that 4 sigma by d is for the normal your water droplet. P is equals to 4 sigma by d, so that was also a formula. So 4 sigma cos theta by rho GD is the height. Now let's see what is given. D is obviously given here. D, as you can see, D will be actually the same for both, 2.5 mm dia, right? So directly convert it into meter. So 2.5 into 10 to the power minus 3 meter, which is, this is my D, and rho is 1000 kg per meter cube for water. We know that. G is 9.81. D we are having D is equals to D already we have written, okay, no need for this writing it again and again. Cos theta is equals to 1, so is equals to 1, and then we have this sigma. Now sigma, or the surface tension, it is also given, very easy, right? 0.0725 Newton per meter. So sigma here is 0.0725 Newton per meter. So everything is given, so H will be your 4 sigma, sorry, write it properly. H will be 4 sigma by rho GD is equals to 4 into 0.0725 Newton per meter, 1000 kg per meter cube into 9.81 into D, and D is 2.5 into 10 to the power 3 meter, 2.5 into 10 to the power minus 3, this looks like 5, okay, corrected it, 3 meter. And if you just calculate it, take some time to calculate it with the help of the calculator, 0.0725, right, divided by 1000 into 9.81 into 2.5 into 10 to the power minus 3. So the answer will be 0.0118. So this will be, this answer will be in meter, 0.0018. You just go another digit, it will be 2. H is this one, this meter. Now this is the height for the water. Similarly we'll do for our mercury as well. So for the mercury, we'll just write the data here. D is same, 2.5 into 10 to the power minus 3, no need to write it again. Sigma, as you can see, which they have given in the question, 0.052 Newton per meter, 0.052 Newton per meter, sigma. Rho, now G is obviously is equals to 9.81, and rho is will be equals to, specific gravity is given as 13.6. Now rho will be 13.6 into 1000 kg per meter cube. So how is this? As I had told in the previous thing also, specific gravity is equals to your density of the liquid by density of water, which is 1000 kg per meter cube. So now if you know the specific gravity, if you to find out rho will be the specific gravity of the liquid into 1000 kg per meter cube. That's exactly what it did. Specific gravity we know, 13.6 into 1000 kg per meter cube. So like this you got this thing of rho. So theta, Now theta is given the angle of contact in the question, theta is given as 130 degree, or else we would take as 120 degree. So since this is given 130 degree, so we'll take as 130 degree itself. So h, since it is the fall, make sure you give a negative sign here, 4 sigma cos 130 by rho g d. So minus 4 into sigma. Now sigma is what we have written, 0.52 Newton per meter into cos 130, directly like cos 130 because we will do it in the calculator. Rho we know 13.6 into 1000 kg per meter cube, right, into your g obviously is 9.81 acceleration due to gravity, and this is your 2.5, d is 2.5 into 10 to the power minus 3 meter. So all this will come out as minus 4.0085 into 10 to the power minus 3 meter. So this will be the answer for the mercury. So now we have, once you solve these two numericals, you have the experience of both your rise as well as this fall. Now let's do another numerical just to keep in the formula better, right? The more we practice, the more we remember the formula with the help of the numericals. So the capillary, write down the question, the capillary rise in a glass tube is not to exceed 0.2 mm of water. The capillary rise in a glass tube is not to exceed 0.2 mm of water. Then you need to determine the minimum size given that surface tension for water in contact with air is equals to 0.0725 Newton per meter. So the capillary rise in a glass tube not to exceed 0.2 mm of water. So when it says that the capillary rise will not exceed 0.2 mm of water, means h equals to 0.2 mm. And what else does it say? Because what it does is the minimum size given that, so determine the minimum size given that is surface tension for water sigma is equals to your sigma or the surface tension is equals to 0.0725 ऐसा ही में दिया हुआ है. So sigma equals to 0.0725 Newton per meter. So sigma is this, and since this is capillary glass tube minimum size given the tension for water, right? Liquid is water, so rho is equals to 1000 kg per meter cube. Now rho is kg per meter cube, g is equals to 9.81 meter per second square. We know that acceleration due to gravity. So this is this we know, okay. This we know, meter per second square, right? This is the unit of acceleration due to gravity. Do we know that? So now determine the minimum size. So minimum size means we need to find out d. So already we know d is equals to, since this is water, so cos theta will be 1. So cos theta will be 1, no need to write it, 4 sigma cos theta by rho gd. So put down the values, 4 into 0.0725 Newton per meter. Here rho is 1000 kg per meter cube into 9.81 meter per second square, and into 0.2, that is this d, sorry, h. So h is 0.2 mm is equals to 0.2 into 10 to the power minus 3 meter, right? So just write 0.2 into 10 to the power minus 3 meter. So if you just calculate this, so it will come as 0.1478 meter. So this will be the d which they have asked in the question. So let's try another question which will give us I'll give some hints if possible. If not solve it, then I may give it as a homework, right? So I am sure you will be able to solve it. An oil of viscosity 5 poise. is used for lubrication between a shaft and sleeve. Okay, the dia of shaft is how much? 0.5 meter, and it rotates at 200 rpm. Calculate the power lost. Power lost, we had done the numerical in the earlier session in oil for a sleeve length of 100 mm. 100 mm. The thickness of oil film is 1 mm. Right. So first of all, what you need to do here, I hope you have the question written. So when you have the question written, just see the question and what are the things given. First of all, you find that 5 poise is the viscosity. So this means this is the dynamic viscosity. Mu is equals to 5 poise. Now we know 10 Newton second per meter square is equals to 1 Newton second per meter square is equals to 10 poise. So if you convert into Newton second per meter square, this will be 0.5 Newton second per meter square. So mu we know easily, and the dia of the shaft, then this will be d, obviously d is 0.5 meter, so directly they have given in meter, so no need to convert it. And the rotation speed is given in rpm, 200 rpm. Now calculate the power lost. So P, they are asking question mark power lost in oil, and length obviously they have given as 100 mm. So 100 mm means your 0.1 meter, 100 mm, and the thickness of the oil film T, or you can just write here directly as dy, because thickness of the oil film is 1 mm, or is you can call it as 0.001 meter. Directly I will write 0.001 meter. So let's try to give you some hints here. Already I have given the thing answer. Okay, so let's try to solve it here. Now here what do we have? We had the formula. We know what is the formula for the power lost, right? So I'll just give you some of the hints here. Formulas, let's just revise for the power lost. So P, or the power lost, is equals to, we know the formula for this. So it is 2 pi nt, 2 into pi into n, there is a rotation, and there is a t is the torque by 60 watt. Okay, now how the torque is found out? Everything else torque is equals to your force into d by 2. Now d we know already, the this thickness here 0.5 meter. So d we know, this d by 2 thickness, d we find out this. And how do you find out the force? Now force is equals to torque into area. Now how we find out the area? Area is pi into d into your L. Okay, if it is a cylindrical part, pi d into L. Like this we find out this. And so we first need to find out tau here. So these are the formulas. Let's find out tau. Now so to find out the tau, we need to write the formula mu into du by dy, right? So now tau is equals to mu. What do you know? Mu is 0.5 Newton second per meter square. Sorry, just write it down. Okay, Newton second per meter square. Now into du by dy. So now we know what is your dy. So dy we already have written here. Dy is equals to 0.001 meter. So this is 0.001 meter. Dy we know. Now what about our du? Okay, so du, if you remember, du has a formula of, we can find the formula by which you can find out. So then that formula I missed earlier, so we simply I'll write down the formula now. So that is called the tangential velocity of shaft, right? So the tangential velocity of shaft, then it is u. So u is equals to pi into d into n by 60, pi dn by 60, and it is in meter per second, right? So we'll simply write down the values. Pi into your d is the dia here, capital D or small d is equal to small del, right? 0.5 meter. So this is your 0.5 meter into n is in rpm. Here, as you can see, I have written in the given data n equals to 200 rpm. So 200 by 60. So I'll just calculate this and write this here. So it will be shift pi into, okay, let's calculate this, pi into 0.5 into 200 by divided by 60. So this will be your 5.236 meter per second u comes. So you know du will be 5.236 minus 0, so du will be 5.236 meter per second. So if we put the value here, we'll find out tau. Okay, tau or the stress. So tau will be what is the value? 0.5 Newton second per meter square. 0.5 Newton second per meter square into du. Du is 5.236 meter per second by dy. Now dy we have 0.001 meter, 0.001 meter, and now if you just do it, so it will be 0.5 into 5.236, right, divided by 0.001. Now this will be 2618. The answer, I had told you earlier also, this numericals come very often. As you can see, this using these formulas also this numerical has come. Okay, 2618, and the unit will be Newton will be there obviously, and meter this will cut Newton per meter square. So we have tau here. Okay, tau we got. Now what do you need? Now we need our force equals to tau into A. So it will be 2618 Newton per meter square into pi dl. Pi into d we know 0.5 meter into your L. So L, as you can see, L here, A is equals to pi d into L. L you know 0.1 meter. So L is the length of the shaft, is 0.1 meter. So force is equal, multiply it, 2618 into, directly multiplying the pi into 0.5 into 0.1. This will be 411.234 Newton, right? Newton per meter square into meter square. This will be Newton. Now find out the torque. So torque T will be here F into d by 2. So it will be F into 0.5 by 2. So it will be, sorry, F, I should have written it, F here is equals to 411.234 into 0.5 by 2, right? I should written all things. So that let's calculate here. 411.234 into 0.5 by 2. It will be 102.808, right, Newton meter. This is the torque. Now next thing, which is the answer, is the power lost. Now power lost P is equals to 2 pi nt by 60 watt. Now we know 2, we know pi, we'll put directly in the calculator. N is 200 rpm, T which you have calculated 102.808, 102.808. This unit obviously is in Newton meter, and by 60. So if you just do it, 2 into pi, 2 into pi into 200 into 102.808 divided by 60. So it comes as, so ultimately it will come as 2153.206 watt power lost is found out. So this is the answer. So like this we can solve all of the questions, and we'll meet in the next lecture of fluid mechanics. Aim is to make the things easy so that the exam oriented and the most important numericals we can solve it. So best of luck, keep practicing, bye bye.